All right, today we're going to be working on tree diagrams. I'm just recording this so I can post it to the blog, and I will be showing you our new blog. I changed back to Weebly. Your parents can still contact me on Seesaw if they need to. You can still contact me on Seesaw if you need to. But I have changed over to back to what I used last year because it was a little bit less cumbersome to deal with. So I'm going to be showing you that after we're done with our notes. Today we're going to be talking about tree diagrams. So go ahead and write tree diagrams on the next page in your composition notebook. So you should be writing tree diagrams in the next page of your composition notebook. Go ahead, Calvin. All right, tree diagrams. Tree diagrams is a representation of all possible outcomes So a tree diagram is a representation of all possible outcomes. And you're going to learn today how to make a tree diagram. It's really easy, but it's really easy to also make a mistake when making the tree diagram. So we're going to be going over exactly what process you need to take. So, yes, Allison. Yes. So let's start with a basic example. We're trying to figure out what do we want to eat for lunch. So our options for our entree is pizza, a sandwich, or spaghetti. Our options for drinks. Please listen. We're writing down what I'm putting. So I'm not asking for your opinion. So our options for drinks is soda, lemonade, or milk. And our sides, we have pretzels, fries, or fruit. So we want to make a tree diagram, a representation of all possible outcomes. So you can get one entree, one drink, one side. So we're trying to figure out how many possible outcomes can we make. So we're going to start our tree diagram, our first branch, with our entrees. So go ahead, let's write out our pizza, sandwich, and spaghetti. This is representing our first branch of our tree. This is representing our first branch of our tree. So now, if I get pizza, what are my drink options? Soda, lemonade, milk. If I get a sandwich, what are my drink options? Soda, lemonade, milk. So we're going to go ahead from pizza, sandwich, and spaghetti. We're going to put an additional 3 branches. And instead of writing out soda, lemonade, and milk, I'm going to just write S, L, M. And then for my sandwich, I'm going to put the same thing. S, L, M. And then from spaghetti, I'm going to do the same thing. S, L, M. So this is only representing the entree and the drinks. What am I leaving off? The side. So now if I get pizza and soda, what sides can I get? All right, so let's put that. So pretzels, fries, fruit. So I put F for fries and FR for fruit, so I can differentiate between the two. So pretzels, fries, fruit. So instead of just putting both of them with the same letter, I'll represent one with FR and one with F. So then for milk, I can get the same pretzels, fries, fruit. Same thing with the sandwich. Soda, I can get pretzels, fries, fruit. Pretzels, fries, fruit. Pretzels, fries, fruit. And then pretzels, fries, fruit. Pretzels, fries, fruit. And last one, pretzels, fries, fruit. So we have all our different options. So now if I wanted to figure out how many total outcomes I can have, or total combinations that I could have, I can go ahead and count the very last row. So I have 1, 2. Now this is what we call the basic counting principle. Oops.
Believe it or not, you do it in college too.
So your basic counting principle, we are going to count, oops, I'm spelling everything wrong. Count the ends of the tree diagram. So I'll put in parentheses the last branch. So if we count that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So how many total outcomes do we have? 27. So using the basic counting principle, we have 27 outcomes. So that's 3 options for everything. Now there's another way we can figure out how many total outcomes without counting the last branch, and that is called our fundamental counting principle. And with the fundamental counting principle, we are going to multiply each event. Meaning, we have an entree, that's one thing we want to get. We have a drink, that's another thing we want to get. And our side. Each of those are representing one event. So how many options do I have for an entree? 3. How many options do I have for drinks? Times 3. How many options do I have for the sides? Times another 3. So 3 times 3 gives me 9. 9 times 3 gives me 27. So we know we have 27 outcomes.